Okay, this is a lesson for Algebra 2, day 21, finding the zeros and roots by graphing a table and solving. Students will be able to find zeros and roots by making a table, graphing, and solving the equation. If you hear background noise, that's my neighboring teacher's music, so I'm sorry about that in advance. Should turn off soon, so here we go. Steps for graphing. Pause the video, write these down. We're going to repeat these steps over and over again as we do the different problems. Okay, so number one, I'll work it out for you. I'll work out 4 problems for you, and then we'll move on from there. Okay, so graphing. Okay, when we graph any sort of quadratic, the first thing, this is one way to do it. When you could graph anything by making a table. So y equals x squared is the problem, and we need to know what our a, b, and c are. I'm going to hide that right there. So we only know what our a is because x squared, the coefficient is 1, but we need to know b and c. There is no b and c, so we could actually rewrite the equation and add a b and a c. And so this is our a, this is our b, and this is our c. You know, b and c are going to be 0, so it doesn't really affect what it is, but a is a positive 1, okay? So that's your first step, is to make a table, xy table. Make that a little straighter here. Put x's on one side, y's on the other. What we're going to do is we're making coordinates here. Since we're making a parabola, you have to remember a parabola is either going to go opening down or opening up. If it opens up, it's a positive parabola. If it opens down, it's a negative parabola. Okay? So, first thing you want to do, since we're wanting to do a parabola, we know it's positive because a is positive 1, so it's going to open up. We don't know what it's going to look like exactly yet. But we want to figure out the vertex. What is this point going to be? We don't know that, so we're going to try to figure that out right now. Okay, so what we do is we start with step 2, which is find negative b over 2a. Plugging in negative b, b is 0. 2 times a is 1. So it's going to be 0 over 2. And the answer is 0. So we know that the x point for the vertex is going to be 0. Step 3, picked 1 or 2 to 3 numbers around it. So the next bigger number is 1. The next bigger number is 2. And then we pick 2 numbers that are smaller than that also. Following that, we need to plug these numbers in, step 4, and find the y values for each of these. So what I like doing is I start with the vertex always. This is going to be our vertex, by the way. So I take the original equation, y is equal to x squared, but instead of putting wherever I see an x, I'm going to actually put in the value that I want to input in the table. In this case, it's going to be 0 first, so it's going to be 0 squared. When we do that, it's going to be equal to 0. So we know our vertex is going to be at 0, 0. Then I'm going to work with 1. Y is equal to 1 squared, which is equal to 1. So when we put 1 in, we get 1 out. Okay. Then I'm going to put in 2. Y is equal to 2 squared. When we do that, we get 4. Okay. Looking at negative 1 now. Y is equal to negative 1 squared. Negative 1 squared is 1, so we know it's going to be 1 here. Y is equal to negative 2 squared, and our answer is going to be 4. So as you could see, we've solved for our y's. Now we want to find, before that, you need to notice that our vertex here is always going to be have a lone pair, okay? And a vertex, of course, is 0, 0. So we go to the origin here and we plot our vertex, okay? Then you'll notice that on the y's, you notice that these are pairing up with each other, okay? Those need to always be the same, okay? So 0, 0, we plot the next number as 1, 1 that we did, and then we did 2, 4. And we plot each of these as ordered pairs, okay? Again, these are all ordered pairs. You should be able to plot these down. Okay? When we do that, we're getting, it looks like a V, but essentially this is actually a parabola. It kind of has more of a U-shaped with arrows at the end, because we could add more points if we wanted. It opens up. Now that was step, I think it's step 5. We plotted the points and we made the graph. Now that this is almost done, we need to figure out what is our vertex, okay? So, or what is the answer? And it's not our vertex, it's where the graph crosses the x-axis, okay? So we notice that it's crossing right here at 0, 0, okay? So since that's the case, we know that it's crossing there. That would be a root, and x is equal to 0 at that point, okay? They also call these the answer zeros, and the reason why is we look for wherever, we look at the y section of the table and we see, oh, y is equal to 0 here, therefore the answer needs to be the x value, which is 0. So those are the hints you would have. That's number 1. Number 2, okay? And again, if you need to go back, you could pause the video, copy this down, rewind it, do what you need to do. Number 2, you start off, I'm going to erase to get some space going here. Number 2, we have f of x is equal to x squared minus 2. Don't be fazed by this f of x here. This f of x, what you could do is just rewrite it and put y in there. Okay, just so it doesn't phase you out. Okay, it's the same thing plugging in numbers for x. Okay, so it's a function. So we don't have a b, or I mean we don't have a c, so I'm going to put a place marker for that. Okay, I'm going to go back to using black ink on here. Alright, first step, negative b over 2a. Okay, we know our b in this case is negative 2. And since it's negative 2, that's our b, it's supposed to be a negative 2 over 2a. A in this case is 1, which is equal to positive 2 over 2, which is equal to 1. Okay, so step 1, make a table, XY table. Put in 1 as your x. Your y, we don't know it yet, but we're going to put a couple bigger numbers, 2, 3, and a couple smaller numbers. That's supposed to be a 3. 0 and negative 1. Okay, and mark off where your vertex is supposed to be. I like putting that down. Okay, start solving for the vertex. Okay, so vertex, put in the, going toward the original equation, y is equal to, and whenever I see an x, I'm putting in a 1 this time. I'm inputting a 1 into my function. Plus 0, so we have 1 minus 2, which is equal to negative 1. So we know our vertex is going to be at negative 1. Okay, continuing on here. Let's put in 0 this time. Y is equal to 0. Squared minus 2 times 0. And we get 0 minus 0, which is just 0. Okay, when we put in 0, we get 0 out of it. Okay, so this is 1 point. And remember what I said, these 2 points have to equal each other. So you could assume this point is 0 now. Next one, y is equal to, let's plug in negative 1. Okay, don't be afraid of those negatives, by the way. But negative 1 squared minus 2 times negative 1. So we know negative 1 squared is 1 plus 2, which is equal to 3. Okay, so we put a 3 right here. And since there's a 3 over there, we know this is a 3 here. Now looking at the original problem, our coefficient is a positive 1. Our a is positive 1. So since it's a positive 1, we know it's going to open up. Okay, let's plot our points. 1, negative 1, 0, 0, 2, 0, 3, 3, and negative 1, 3. And you can see there is a line of symmetry down the middle. Both sides need to be equal to each other, or starting on one side, we're going to draw our parabola as well as we can. And remember, it's a U-shaped. It opens up, and then we're going to, that's step, I think it's 5, we're going to figure out what are our solutions, if there are any. In this example, you're going to see, oh look, there's a solution there, and then there's a solution there. what's the value of x here? Well, it's the value is 0, and the value here is 2. So we have two answers. X is equal to 0, and it's equal to 2. You can put x is equal to 2. Another way you could do it is you could use a solution set, where we put 0, 2. This represents in math, this is a solution set, okay? That's for number 2. Number 3. Just like number 1, except there's a negative sign. So I'm going to go back actually to number 1. Let's see if I can pull it back here. Okay, back in number 1. See number 1 right here? It's y is equal to x squared, okay? If that's the case, and it's pointing up when it's positive, we could actually use the same numbers when it's pointing down, when it's negative, okay? See? So, let me make some space here. But let's just go through the steps anyways, just to practice the steps, okay? But you could assume that it's going to point the opposite way with similar numbers going negatively, okay? So, first step, make a table with your x and y. Okay. Next step, do your negative b over 2a. It's going to be 0 over 2 times negative 1, which is just 0 over negative 2, which is just 0. Okay. Next step, plot 0 here, add a couple bigger numbers, a couple of smaller numbers. Okay. And plug in 0 into, this is our vertex here. So I put a little v here to remind myself that's the vertex. I'm going to plug in 0 first, so y is equal to negative 0 squared. Remember, I'm putting the x value into its own parentheses. 0 squared is 0, negative 0 is just 0. There's no such thing as a negative 0, so the answer is 0. Okay, that's your vertex. Now we're going to plug in, let's use positive 1, okay? Be careful with this now. Watch what happens when I put in positive 1. Y is equal to negative x squared. So it's negative x squared, and our x, this example, is 1. So we ask ourselves, what's 1 squared first, right? 1 squared is just 1, and then we have a negative sign. So this one's going to be negative 1. Okay, and this one should be negative 1 also, because these two numbers are going to be symmetric. Continuing, y is equal to negative 2 squared. And there's going to be a negative sign in front. Negative 2 squared is going to be 4 with a negative sign, so it's going to be negative 4. So I just put in negative 2, so it's going to be negative 4. And, of course, this one will also be the same as this one here. Okay? We got our coordinates, now we plot them. So we got 0, 0, negative 1, negative 1, 1, negative 1, negative 2, negative 4, and 2, negative 4. And you could see now this is actually going to be a parabola that is pointing down or opening down, and it's only going to be touching the x-axis at this one point here, right? What's the name of this point? This is, looks like x is equal to 0, so your answer is going to be x is equal to 0. That's your only answer in this example. Number 4, last one. Okay? So that's number 5. Number 4 here. Number 4. Number 4 is f of x is equal to x squared minus 6x plus 5. Okay? In this example, we have an a, that's 1, b, that's negative 6, and c, that's 5. Okay? So start with our table. We have x and y table. If that's enough room, I'll make it a little bigger. Okay, start with negative b over 2a, step 2. Our b here is negative 6, so it's going to be negative 6 over 2a. Our a in this example is 1. So it's going to be positive 6 over 2, or it's just going to be 3. Okay. this is our vertex, so we start putting it in the middle. It's your vertex. Pick two numbers around it. So we got 2, 1, 4, and 5. I'm going to work with the smaller numbers. Those are easier. Let's start with 1. Y is equal to 1 squared minus 6 times 1 plus 5. I think that's right. Okay, yep. So 1 squared is 1 minus 6 plus 5. So when we get this, you figure out the answer is 0. Okay? So since it's 0 when I plug in 1, it's going to be 0 when I plug in 5. And look, these are 0. This should already give you a hint that these are the zeros. So since these are 0, you should already assume that maybe 5 and 1 are going to be your answers, or should be already your answers. Okay? Those are probably the answers already, but we need to finish this off. What happens when I put in the vertex? Y is equal to 3 squared minus 6 times 3 plus 5. Okay, simplify. We got 9 minus 18 plus 5. 9 minus 18 is negative 9. Negative 9 plus 5 is negative 4. So our vertex is going to be a 3, negative 4. Okay, plug in 2 now. Running out of space here. So we got y is equal to 2 squared minus 6 times 2 plus 5. 2 squared is equal to 4 minus 12 plus 5. 4 minus 12 is negative 8. Negative 8 plus 5 is equal to negative 3. Okay. So we got negative 3 over here. Now, we could plot these points in. So we got 1, 0. Then we got negative, or we have 2, negative 3. 3, negative 4. And so forth. And you're going to notice that our vertex is way out of the way this time. But we have two solutions in this example. One here and one here. Okay? What's it called here? This is a 1. This is a 5. Remember, we have 1 and 5. These are our zeros, right? Because when y is equal to 0, that's what we're looking for. So x is going to be equal to 1. X is equal to 5. These are your two answers. And that concludes this lesson. We'll talk more about it on the next lesson.